Guys, let me get the host access, then we'll start. So till the time we get host access, let's begin. So did you guys solve problems? Did you face any problem while solving the questions of the exercise? Yeah, anyone? Murli, how about you? Did you solve problems from this chapter? Which chapter we are doing, you know?
Sir, not quite sure, sir.
Yes, repeat.
Not quite sure, sir. I wasn't following, sir.
Okay, so we are doing 3D geometry, right? So and in previous class we saw the distance formula, and somewhat section formula we'll be doing today, and these are the two theorems that we'll be seeing in this chapter. Okay, and that will be all the we'll finish the chapter. Okay, so uh, where is the host access? Just a minute. Yeah, please do it fast. Okay, everyone is waiting in class. Okay, what we'll do, we'll go through the chapters, the exercise one by one. Let me know if you want any problem to be discussed. So in exercise 12.1, do we have any doubt? Anybody is having any doubt at all? Question number 1, 2, 3, 4. Any doubt in any of the problem? Any doubt at all?
No, sir.
Okay. Okay, so wait, where is the book here? And that was okay. So till 4, we don't have any problem. And till exercise 12.2, do we have any doubt? Exercise 12.2. Question number 1, 2, 3, 4, 5. I think we have discussed these also, right? Some of the problems we have discussed, like verifying that what is isosceles triangle and right angle triangle, how you are going to prove using distance formula, right? So for a right angle triangle, if you'll have to find the side of all the three means edges of all the edges of the triangle, and if it follows Pythagoras theorem, then it is a right angle triangle. Otherwise, it's not a right angle triangle. And the vertices of parallelogram, we have discussed that one as well. Question number 4 is find the equation of the set of points which are equidistant from the point, right? That means what? What is this question number 4? Anybody? 12.2. Anyone, please tell me what is how you'll solve exercise 12.2, question number 4. Yes. See, find the equation of set of points which are equidistant from point from the two given points. How you will solve this problem? So let's assume that there is some point x, y, z, means let's say some point P, whose coordinate is x naught, y naught, z naught, right? So according to the problem, what PA should be equal to PB, and A and B, the coordinates of A and B are given in the problem, right? So using that, we can find an equation in x, y, and z. All right. Okay. Okay, everyone got the host. And question number 5, exercise 12.2, question number 5. Find the equation of set of point P, the sum of whose distance from a point A is given and B is given is equal to 10, right? So it's again exactly similar to question number 4. So we will assume a point P anywhere in space, which is x, y, z. Okay, the coordinate of A and B is given respectively. So PA plus PB should be equal to 10. That's what it's written, right? The sum of distances from A and B is equal to 10, right? Got it? So if you have any doubt, we can discuss these problems, or we will move to section formula. Okay, now I've got host access, so let's start. So everybody is able to see the screen? You can see the, yeah. So we were studying 3D geometry, right? Just a minute. Where is that? Okay, 3D geometry. Okay, what are these doing here? Anyway, so do you want me to solve any of the problem? Please tell me. We can go through it. Exercise 12.2. Any problem at all? Please tell me. Question number 3 we had discussed. See, it's given the coordinates. See, question number 4, what it says. You are given 2 points, point A and B. Okay, so coordinate of A and B is given. Now you have to find a point, let's say some point P. Let's say the coordinate is x naught, y naught, z naught, right? Now it's given if you join this PA and if you join PB, both will be equal. In the problem, it is given PA is equal to PB. And we know how to find P and PB, right? We will use the distance formula. So the coordinate of point A is, what's the coordinate? 1, 2, 3. And the coordinate of point B is 3, 2, minus 1. Okay. So how we will use just the distance formula? What is it? Okay. So PA is equal to PB. Now how you will write PA? So PA will be x naught minus 1 whole square plus y naught minus 2 whole square plus z naught minus 3 whole square. Now square root of this should be equal to square root of 3 minus x naught whole square, or x naught minus 3, whatever you want, you can write, plus 2 minus y naught square plus, anybody is having doubts, please tell me, okay, z naught square. So anyway, square root you can just cancel out. So you will get an equation in x. Okay, so let's solve it. X, y, and z. Sorry, x naught, y naught, and z naught will get a equation. So this will be x naught square plus 1 minus 2x naught plus y naught square plus 4 minus 4y naught plus z naught square plus 9 minus 6 z naught, and this should be equal to 9 plus x naught square minus 6x naught plus 4 plus y naught square minus 4y naught plus 1 plus z naught square plus 2z naught. Okay, understood? Is anybody's having doubt why it is plus? Because both will get multiplied and it will be positive value. So we can just remove x naught minus x naught will be 0, y naught minus y naught will be 0, z naught minus z naught will be 0. Okay, so what are we left with? X naught. Okay, z naught is all right. So y naught. Okay, so this will also get cancelled. So plus 4, this side also plus 4, this also we can cancel. Here also it will get cancelled. So what are we left with? X naught. So this will become 4x naught, right? This and this we have solved, plus z naught, right? So z naught is minus 6 minus 2, so minus 8 z naught plus here we have 1 and 1. Okay, 1 will also get cancelled. We can cancel out this 1 as well. Okay, so that will be equal to 0. Sorry, this will be equal to 0. So that's the equation we wanted to find, the relation between x naught and z naught. So, or we can also write x naught minus 2z naught is equal to 0. Same thing, right? We can just take 4 common and eliminate it. All right. Similarly, question number 5 is exactly same, right? Now in question number 5, you are given 2 points A and B. Point A and point B is given. So it is 4, 0, 0, and B is minus 4, 0, 0. Now there is a point P somewhere in space. Okay, so let's say P is here, whose coordinate is x naught, y naught, z naught. So if you join PA and PB, now this time it says PA plus PB should be equal to 10. That's it. So we'll use same distance formula and we'll solve it. Okay. Now let's come to the last part of this chapter, that is section formula. Okay, section formula. See, section formula in 2D plane we are already aware of, right? In 2D plane we know that, right? What is section formula in 2D plane? Anybody? In 2D plane, what will be section formula? So this is x, y. Suppose there is any line like this, and you are dividing this line into 2 parts, right? So let's say this is point A and B. Now there is some point on this line, let's say P, whose coordinate is x and y. Let's say the coordinate of point A is x1, y1. Okay, and coordinate of point B is x2, y2. Okay, so in and this point P divides line AB in the ratio m is to n. Okay, so what will be the section formula for this? So the coordinate of point x will be equal to, how do you find coordinate of x? This will be equal to x2 into m plus x1 into n upon m plus n. This is section formula in 2D plane. Okay, and for y coordinate we'll use similarly y2 into m plus y1 into n divided by m plus n. Now in 3D it is exactly similar in 3D. Okay, but in 3D we have to take care see in 3D, let's say this is a new axis. So let's imagine these are the planes. Sorry, these are the axes. Let's say this is X, this is Y, and this is Z. Now, do you know how do we decide which one will be X, positive X, which one will be positive Y? Do we know that? Do we have the idea about which side will be positive, which will be negative? Anybody? Anyone is having idea? See, we always follow right hand thumb rule. Okay, we can follow that. So what we will do, we will keep our thumb in the direction of any positive axis, like let's say X axis, and keep our palms on Y axis towards Y. And when we rotate it, or the direction of the palm, the perpendicular direction of the palm represent Z axis, positive Z axis. Okay, so that's how we decide the coordinate system, the rectangular or the Cartesian coordinate system. Understood? Okay, so let's say this point is origin, and let's say we are having a line anywhere in space. Let's say a line, something like this. Okay, in space somewhere. Now, okay, now let's say the coordinate of this, well, let's write down this is like, so this is point P and point Q. Okay, now the coordinate of point P and Q in 3D, let's write here. P is x1, y1, z1, and Q is x2, y2, z2. Okay, now see, if we have to divide this line in 3D, so we need a plane to intersect it in all three. Okay, so we need a plane. So let's say this is the plane. Oh, how I should draw? Okay, so let me draw the plane. So let's draw the plane like this. Something similar to this. Okay. Now see, this plane intersect this line here at, let's say, some point. Let's say this point. Let's say this point right here. This point right here. So let's say this is R. This coordinate we don't know. So let's say the coordinate of R is X, Y, Z. So we need to find this X, Y, and Z. All right. So we'll draw a line perpendicular to it. Now this plane is on Z plane. What is Z plane? The XY plane is called Z plane, right? We have discussed this part in previous class. Okay, so this is the plane we are talking about. Okay, this plane. On this plane. So this is the Z plane. All right. Now, if we draw a line perpendicular here, let's say this line from R to some point, okay, on this plane. So let's say because point N, let's say this is N and this is M, L, M, N. So N, L, and M, point L, N, and M are on XY plane, or we can also say positive Z plane. Okay, so X, L, M, and N all lies on this plane. Okay, now see, suppose it divides this line in the ratio of M is to N again. So M, N. All right. Now we see, if we extend this line, here, okay, so what we'll see, we have two triangles, right? So let's name this point S and let's name this point T. Now see, triangle, in triangle PSR and triangle RTQ. So these two triangles, if you see, and we okay, hopefully I'm audible to you guys. Okay, see, so in these two triangles, we'll see that these triangles are similar. So the ratio of m is to n, we can write, or instead of directly writing m is to n, we can write ratio of pq upon r, sorry, not pq, pr, the ratio of p, sorry, the ratio of pr upon rq, this should be equal to, rq should be equal to st upon qt. Okay, now st, no, not st, st, sr, sorry, this should be sr upon qt. Yeah, sr upon qt. All right, so this we can write sr upon qt, again we can write sl minus pl, right? So sr, this one, sr, we can write sl, so sl, this from this height, and sl minus pl, so pl, this one, so that we can get this. Okay, something is wrong, just a minute. M is to n. Okay, so PR upon QR, PR upon QR should be equal to SP upon QT. Okay, now how do we find this SP? SP should be equal to SL minus PL. Okay, SL minus PL divided by, this is QM. So QT will be equal to QM minus TM, right? Now this should this should also be equal to, now let me write it here. So this will also be equal to NR minus PL, NR minus PL upon QM minus NR. Okay, so which one is QN? This one, where is the pointer? So QM, this one, minus NR. So which one is NR? This one. Because we are measuring from this plane, we are taking all the dimension on this plane with reference, because here z is equal to 0, and above, right now we are talking in the positive z direction, so here z is increasing, right? This is all the measurement of z in this direction. Understood? So that point L, N, and M are on this xy plane. Got it? So this will be equal to, now we know PR, the ratio of PR upon QR is M by N. M by N. This should be equal to, so what is NR? NR, what will be the coordinate of NR? How do we write NR? NR will be Z, right? Because this will be 0 minus Z1. PL will be Z1. So PL will be Z1. So the coordinate of this point is Z1, right? X1, Y1, Z1. So the coordinate of point L will be, let me write, X1, Y1, X1, Y1, and this will be 0. Z is 0 here. Okay. And here, N, the coordinate of point N will be X, Y, 0, and M will be X2, Y2, 0. Because on XY plane, the value of Z is 0. So the distance NR will be Z, and PL will be Z1. Okay, similarly, divided by this point, that will be Z2, QM will be Z2 minus Z. Exactly similar, because because the distance formula is X minus X1 and all for all the X, Y, and Z. Since X and X1 is same, so this value will be 0. Y will also be 0. Only we'll have Z minus Z1. So that's why we have only Z minus Z1 upon Z2 minus Z. Okay, so from here we can write Z is equal to M times of Z2 plus N times of Z1 upon M plus N. Okay, so that's how we are going to find the coordinate of Z. So the coordinate of point R, let's write the coordinate of R here. The coordinate of R will be, so X coordinate will be M x2 plus N x1 divided by M plus N. Y will be M y2 plus N y1 divided by M plus N. And Z will be M times of Z2 plus N times of Z1 divided by M plus N. So this is called your internal division. Okay, section formula when the lines are divided internally. We don't have to study when the lines are divided externally. Okay, so we are not going to do that. So I hopefully this formula is really clear to you guys, and let's start solving problems. Okay, so suppose we have 2 points A and B. Okay, A is 1, 2, 3, B is 4, 5, 6. Okay, so find a point in the middle of A and B. So let's say there is some point P whose coordinate is X, Y, Z. I want you to find the value of the coordinate of this point P when it divides in the ratio of 1:1. That is midpoint. Okay, or the question can be like P is the midpoint of AB. Find it. Solve this problem. Anybody? Anyone, please tell me the answer. How you'll solve it? Murli, tell me how you'll find it. Anyone, please tell me the answer. It's very easy, right? I know you guys have solved it, so please let it out. Somebody, please tell me. Anyone? Shri Kruti? Shreya? Hari, Raghav? Anyone, please tell me. See how you'll solve it. If P is the midpoint, how you'll find the coordinate of point P? So this will be X will be equal to X1. So this will be 4 into 1 plus 1 into 1 divided by 1 plus 1. And so similarly 2 into 1 plus 5 into 1 upon 1 plus 1. 6 into 1 plus 3 into 1 upon 1 plus 1. Right? That's how we are going to find. So P will be 4, 5 by 2. And this will be 2 plus 5, 7 by 2. 6 plus 3, 9 by 2. So that will be the coordinate of this point P, because if it is a midpoint, so it will be dividing this line in the ratio 1:1. Okay. So why is no one responding here? What happened? Are you guys well? Too much shock? Do you want to continue this class or shall I end it? Let's not waste my time as well.
Sir, yes.
Okay, I'm ending the. Yeah, tell me, who's this?
Sir, I'm listening, sir.
Yeah, so you have to reply at least, right? If I'm asking you, I'm taking your name, you have to answer at least, or you should say, I haven't understood anything, whatever you are saying. Say something, yeah.
Yes, sir. Yes, sir.
If you're not, I'll just end the class.
Sorry, sir.
See, you can listen to other classes. I really don't like it. I know it can be a little tiring for you guys, but if you have registered for it, so just at least take advantage of it. At least you can ask me problems, even if you have solved these problems, you know everything, or you even if you haven't understand anything, you have to let me know.
Yes, sir.
Okay, see, find the coordinate of centroid of a triangle whose vertices are given. Okay, so we are given a triangle. We have a triangle here. Okay, and let's say the coordinate of this triangle PQR is x1, y1, z1, x2, y2, z2, x3, y3, z3. So we have to find the coordinate of its centroid. Okay, what is a centroid? What is centroid?
So the point, sorry, sir.
Yeah, see, it's fine even the answer is wrong. You have to try it, right? Just tell me, how do we define a centroid of a triangle?
So it's center of
Midpoint.
triangle and all the.
Yeah, Murli, tell me what you are saying.
So where all the lines from the vertices intersect. Sir.
See, it's not just any line. See, first you have to find the midpoint of all the lines. Okay, so all the this edges. These are the edges, right? PQ, QR. So midpoint of PQ, let's say A, B, C. Let's say these are the midpoints of its edges. Now we'll draw a line from their midpoint. Okay, from midpoint to the opposite point. Okay, so let's draw this from here to this point, from C to Q, and from R to A. So when we, sorry, my mistake. So when we draw these lines, okay, so when we draw these lines, so it will pass by a point. It will pass through. Something is wrong. Just a minute. I think the system hanged. There's something wrong with my GoodNotes. Let me rejoin the call, okay? I'll rejoin the call. Just wait for some time.
Okay, sir.
Okay, sir.
I'm really sorry, guys. That was my mistake. So I'm really sorry. Okay. How do we find the centroid? Now, when we are discussing about this point is called centroid. Okay, this point. So let's say this point is P. Let's say this point is P, whose coordinate is, sorry, not P. P we have already. So let's say this is some point O. Okay, whose coordinate is X, Y, Z, or we can write X naught, Y naught, Z naught. X naught, Y naught, Z naught. So how do we find this centroid? We know that this median, it intersect, the centroid intersect the median in the ratio of 1:3. Okay, so it intersect in 1:3 ratio. So now find out. Use the section formula. See, B is the midpoint. B is the midpoint of QR. So what will be the coordinate of B? What will be the coordinate of B? What will be the coordinate of this B? So the coordinate of B will be what? Because this is 1:1 ratio. So this will be x2 plus x3 divided by 2, right? Isn't it? Comma y2 plus y3 divided by 2 and z2 plus z3 divided by 2, right? So this will be the coordinate of point B. Now we know BP is sorry, not 1:3. It is, I'm really sorry, it is 1:2, because 1:2. The centroid divides the median. Centroid divides the median in the ratio of 1:2. Okay, so this is dividing in 1:2 ratio. Now we know the coordinate of point P. See, now we have B, we have P, right? We have P x1, y1, z1, and it's being divided in the ratio of 1:2. So let's write the coordinate. So how you write now? This will become 2 times of x2 plus x3 upon 2 plus into x1, right? Sorry, plus x1, right? Yeah, divided by 2 plus 1. Similarly, we'll write y. Now this we are writing the coordinate of point O. So y will become 2 times of y2 plus y3 divided by 2 plus y2 whole divided by 2 plus 1, right? Comma. Now this will be, the z coordinate will be 2 times of z2 plus z3 divided by 2 plus z1. Sorry, this is y1, not y2, whole divided by 2 plus 1, because it is dividing it in the ratio of 1:2, right? You see this 1:2, we have this point B, we have this point P. So we'll be using section formula. So coordinate of this point multiplied by this, right? And plus coordinate of this point multiplied by this and whole divided by 2 plus 1, the ratio. So this we can write. So coordinate of O will be, these two will get, you can just, the ratio will be 1. So this you can write x1 plus y, sorry, plus x2 plus x3 will be divided by 3, comma, y1 plus y2 plus y3 divided by 3, comma, z1 plus z2 plus z3 divided by 3. So this is the coordinate of centroid. Okay, so this is the coordinate of centroid. O is the coordinate of centroid. All right. Okay, so let's solve some of the problems from exercise 12.3. See, question number 1, find the coordinate of point P, a point which divides the line segment joining the point. So again, you are given 2 points, okay, P and some point Q, and a point, let's say point A. Let's say point A here, it divides this -2, 3, and 5, and the coordinate of point Q is 1, -4, 6 in the ratio of 2:3 internally. Okay, so find out the ratio, find out the coordinate of point A. Find out the coordinate of point A. Okay, we have external division as well. Okay, all right. Yes, please someone tell me how you will find it. It's really simple, right? You just multiply. How you will find, so let's say the coordinate of this point is x, y, z. So x will be equal to -2 multiplied by 3 plus 1 multiplied by 2 divided by 2 plus 3 y. Okay, so this will be x, this is y, so this is a. We are solving a internal division, right? So internal division, so this will be 3 times of 3. So we are multiplying y coordinate with this 3 and 2 with -4 plus 2 into -4 divided by the sum of ratios 3 plus 2, and z will be 5 into 3 plus 2 into 6 divided by 3 plus 2. So that will be 6 plus 1 plus 2 will be -4 by 5, -4 by 5. This will be 9 minus 8. So 1 by 5. This will be 15 plus 12. So 15 plus 12 will be 27 divided by 5. So this will be the coordinate of point A. Now it in question B, it says it divides externally. So if the line divide it externally, how you will write the section formula? So it will become mx2 minus nx1 divided by m minus n, okay, comma, my2 minus ny1 divided by m minus n, okay, comma, mz2 minus nz1 divided by m minus n. Okay, that's how we find x, y, and z coordinate, x, y, and z, if the division is external. External division of line. Okay, what do we mean by external division? So let's say this is point P, point Q, and there is some point on this line. Let's say point A. Okay, so this is point P, whose coordinate is, let's say, x1, y1, z1. This is point Q, x2, y2, z2, and point A, whose coordinate is x, y, z. Now A is dividing line PQ externally. Okay, now this ratio, this is m and this is n. Not this distance is n, the ratio is n. Okay, so the ratio of PA upon QA is m by n. Okay, don't confuse that this displacement, this distance is m and n. Okay, this is how we divide it externally. All right. Okay, so hopefully you can do that. Now, how do you prove? So question number 2 is 3 points are given. How do you prove the what is that? That the points are collinear. How do you find that the points are collinear if 3 points are given? Okay, see, P, Q, and R. Okay, they are given that these are collinear points. Find the ratio in which Q divides PR. So suppose, let's say this is M, this is N, right? Now point 3, 2, -4. Point Q is 5, 4, -6. and point R is 9, 8 minus 10. We'll do that same 3 into, so 5 will be equal to 3 into n plus 3 into n plus 5 into m divided by m plus n, right? Now from here we will get one equation in m and n. Then the y coordinate, that is equal to 4, will be equal to 2 times of n plus m times of 8 whole divided by m plus n, right? So you have two equations, you have two variables, you can solve it. Although we have three equations here. So minus 6 is equal to, see, this is 5, this is 4, and this is minus 6 here. Okay, so minus 6 is equal to minus 4 times of n plus minus 10 times of m whole divided by m plus n. Now we have three equations, but we have only two variables, so we can easily solve it. Okay, so we can solve for m and n. So this will be the ratio that we'll get from these three equations. So equation 1, equation 2, equation 3. Hopefully you can solve this, right? So I'll move ahead. All right, you're not saying anything, I'll move ahead. I'll assume that
Yes,
you are
yes.
understanding everything. See, we just need to solve this equation, right? We are using only section formula, nothing else. Okay. Question number 3 is find the ratio in which YZ plane, that means X plane. See, YZ plane, when we are saying that YZ plane, okay, okay, let me redraw it. YZ plane, sorry. Okay. See, suppose if this is YZ plane, that means, let's say this side, this is Y, and this is Z. So that means X is coming out of here. So coming out means we represent it by dot. So X is coming out. Let's say like this. It is coming out of this screen X, right? So that's why it is also called X plane. So you can also write it here. Okay, that means X is coming out of the screen. Okay, X, positive X, right? So that's why it is also called X plane when we are writing YZ plane is also called X plane because X is perpendicular on YZ. Okay. All right. Now find the ratio in which the YZ plane, see, in YZ plane, the value of X is always 0. X is always 0. You have to understand that in YZ plane, the value of X is always 0. Devise the line segment formed by joining the point. So there are 2 points. Okay. So point P, let's say some point P, some point Q. Okay. P, Q. So the coordinate of P and Q is given to you. -2, 4, 7. And Q is 3, -5, 8. So these are the 2 points given. Right now it intersect. Now now this point. So this is your 0, X is 0, Y1, Y1 and Z1. Let's say this Y1 and Z1. Okay, because we don't know what is Y1, we don't know what is Z1. Also, we don't know M and N. We don't know this M and N as well, right? So we need to find this ratio. How we will do that? Again, whatever information we have, we'll use that. So -2 times of N, -2 times of N plus 3 times of M divided by M plus N is equal to 0 because that X coordinate is 0. So from here, what we are getting, 3M is equal to 2N. So this we are getting from here. All right. Now we know that -5 into M plus 4 into N divided by m plus n. Okay, wait, xy plane, when we are talking x, y. Something is wrong. Let me check one more time. Okay, see, with m and n we cannot find it. So let's assume it divides it in the ratio of k is to 1. Then it is easier to find it. Okay. See, m is to n. M is to n, we keep writing m is to n, but this is also equal to k is to 1. There, for some value k, that means k is equal to m by n, right? So let's assume that it divides it in the ratio of k is to 1. K is to 1. Okay, so if we use k is to 1, it will be easier for us to find the value. Okay, so let's write k is to 1 upon k plus 1. So from here also we are getting 2k is equal to 3. That means k is equal to 3 by 2. So it divides in the ratio of 3 by 2. It's very easy, right? If we assume that let m by n is equal to k, so that means it is dividing it in the ratio of k is to 1. So m by n, the ratio will be, that means this point right here, let's say this point is a, it is dividing this point p and q in the ratio of 3 is to 2. All right, let's come to next question number 5. That is, okay, not 5, so question number 4. 4 is using section formula, show that 3 points are collinear. These points are collinear. So how do you show using section formula? How will you show this using section formula? So you have 3 points, right? So let's say this point A, B, and C. So we have to show that these are in 2, -3, 4. B is -1, 2, 1, and C is 0, 1 by 3, 2, right? So what we can do, let it divide in the ratio of k is to 1. If it divides in the ratio of k is to 1, so how we can write? 1 is to k or k is to 1, whatever you want, you can write. So we can write, wait. Let's show that this and this are collinear. Okay. Okay, so let's write down the coordinates. So -1 is equal to, what we can write? 2 times of 1 plus 0 times of k upon k plus 1. Right, so this is not right. What was the question? Using section formula so that point A, B, and C are collinear. See, we don't know which ratio it is dividing, right? We don't know that. Okay, we don't know this. So it's just given that there are 3 points which are, we have to prove that these 3 points are collinear. Okay, so we have to prove that it lies on same line. So let's say A and B we have, and let's say there is a point P in the middle of it, which divides this line in k is to 1 ratio. Okay, so what will be the coordinate of this point P? So this will become, this A is 2, -3, 4, and this B is -1, 2, 1, right? So we can write k times of minus 1 plus 2 upon k plus 1, comma k times of 2 minus 3 upon k plus 1, k times of 1 plus 4 upon k plus 1. So this will be the coordinate of point P using section formula. Now we find the value of k for this point C. So the point C, what is it given? 0, 1 by 3, 2, right? So if these 3 points are collinear, that means this minus k plus 2 upon k plus 1, this x should be equal to 0, right? So that means k should be equal to what? 2. From here, k should be equal to 2. We are substituting it here. Okay. We are substituting it here. Now, if k is equal to 2, so for if k is equal to 2, we have got k is equal to 2. The coordinate of point P will become 0, and this will be 1 by 3, and this will be 2. So if you substitute k 0 here, so what will get? 0. If you substitute it here, what will get? Minus 3 minus, what we are getting, minus 3. Sorry, k is equal to 2. No, not k. So 4 minus 3 is 1, 2 plus 1. So this is 1 by 2. See here. Let's substitute this point here. K is equal to 2. So what will get? So x will get 0. Y will get 2 times of 2 minus 3 upon 2 plus 1. And z will get 2 times of 1 plus 4 upon 2 plus 1. So what we are getting? 0, 1 by 3, and 2, which is this point. Okay, which is this point, point C. So point P and point C are coincident. That means point A, B, C are collinear. Therefore, point A, B, C are collinear. All right. Now, question number 5. What is question number 5? It is find the coordinate of the point which trisect the line segment joining the point P, this and this. Okay. So you have to, okay, so there is point P and point Q. P and Q, the coordinate of which is given 4, 2, minus 6. And second one is 10, minus 16, and 6. Okay. Coordinate of points. So there are 2 points here, this and this. Let's say A and B. So these trisect, that means these are the ratio. This is in the ratio of 1:1:1. Okay. So hopefully you can solve this one. You can find using P and Q, you can find point A, because this ratio will become 1:2. 1:2. Similarly, this ratio will become 2:1. So hopefully you can find A and B, coordinate of A and B. Okay. So I think all the problems are really easy in this. You just have 2 formulas in this chapter, right? One is your section formula and one is your this distance formula. So I'll just write the summary here. We have 8 octants here, and the distance formula is PQ, which is square root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. And we have section formula, which is mx2 plus nx1 upon m plus n. Similarly, you will write for y and z if the division is internal. I have told you the meaning of internal and external division as well. So if the division is external, this will be m times of x2 minus n times of x1 upon m minus n. Similarly, you will write for y and z. Okay. So that's all. And the coordinate of midpoint of line segment also we know. So midpoint coordinate will be what? Midpoint. So this will become x1 plus x2 divided by 2, y1 plus y2 divided by 2, because the ratio is 1:1. Z1 plus Z2 divided by 2. That is midpoint. We've also found the centroid of a triangle. Okay, centroid of triangle. Centroid of triangle. That is x1 plus x2 plus x3. If these three are the coordinates of the vertices, all right, divided by 3. And similarly, you will write for y and for z. Okay, hopefully this chapter is over. You solve the problems of miscellaneous exercise. If you have doubt, you can ask me anyway. And tomorrow we are going to start the last chapter, probably probability and statistics. So probability will start tomorrow. Okay, thank you so much. Bye bye.
Thank you,
Thank
sir.
you, sir.